since we're getting into a unit in algebra, or the only unit in algebra really, that there's not like a single answer for things. We're getting into a bunch of scenarios where you have to think about what's happening realistically and compare it to data. When we compare it to data, some of us are going to have slightly different answers than others, and not like when we do point slope and somebody uses a different point than somebody else. I'm talking the slope might be slightly different. Our correlation coefficient might be slightly different. All of these things that we're going to talk about today. Okay, so the first thing, you've got 6 scatter plots, A through F. Now, scatter plot is just all the points plotted up from a set of data. What I want you to do first is I want you to go through and look at the type of correlation it is. Is it a positive correlation? Is it a negative correlation? Is there no correlation at all? So go through and label A through F either positive, negative, or none as far as correlation is concerned. What'd you guys get for A? None. B. All one. Okay, there is a correlation. Okay, this is a non-linear. I know. Okay, y'all. I'm going to explain in just a second. F. Okay, before we move past this, when you guys were going through, did anybody bother to read the axes on the graph? Okay. Yeah. What are you comparing for the A? Distance traveled and number of times tardy. Does that make sense why it would be no correlation? Yeah, they have no bearing on each other. It doesn't matter how far you travel in miles and how many times you're tardy. They're not related at all. That's why there's no correlation. Part B, pitches thrown and number of baseballs used. Well, that makes sense, right? C, scores on a math quiz and scores on a history quiz. Also could be positively correlated. The temperature and people at the beach. If it's super cold outside, you're probably not going to see very many people on the beach. The hotter it gets, the more the more people there are. Okay, this is why it's non-linear. If you think about the peak temperature outside, if it gets really cold outside, what are you running all the time? The heater. If it gets really hot outside, what are you running all the time? AC. If it's really nice outside, you probably have noticed that your air conditioning and your AC or your heater do not kick in. So your electricity is getting used less when it's really nice outside, because you're probably not using a whole lot of lights because you are outside, right? So this is electricity being used. It's going to be really high when it's cold. It's really high when it's hot. So it's nonlinear. This is actually a quadratic relationship, but that doesn't mean anything to us right now. Okay? So just nonlinear, but it is correlated. F is negative, number of absences and exam scores. Makes sense, right? The more you're absent, the more you're missing class, the lower your exam score would be. Okay, now we're going to be comparing or answering questions based on those 6 scatter plots. So you might have to, like, on the first 2 questions, you can just look at the top of your paper. But after that, you're going to be flipping back and forth a lot. The first one we're going to look at is graph F. The data graph on card F, use the data graph on card F to answer the following questions. Record your questions below. Mrs. Collins made a scatter plot to show the relationship between the number of absences a student in her class had and the student's final exam score. Based on this trend, approximately what score would a student with 6 absences expect to receive on their final exam? So go ahead and look at your scatter plot, make a judgment call based on what you have, and be ready to explain. All right, David, what you got? 75. Does everybody agree with David 75? You think that's, did anybody get something different than 75?
I put 75 to 80.
75 to 80, really? 80. 70 to 80, okay. What'd you put? Okay, did anybody get anything like super far away from 75, 80? Anybody get 100? No. Did anybody get 0? Okay, so realistically, anywhere from 70 to 85 would be a good judgment. Because if I'm looking at this data and I put boundaries on the high end and the low end of the data, anything that fell within that margin would be acceptable. The average would be the line of best fit that we would place right in the center of all of that. But that's called interpolation. So this word out here is important. Interpolation, inter meaning inside. You're making a judgment call on data inside the graph. So if it's somewhere where they ask you a question and you can put a point inside your graph, that's interpolation. Okay. First things first, change the word causation to association. That's out here on the side. Yes, causation is a word. Okay. A teacher collected, we're using card C. A teacher collected data on 20 students for 2 different quizzes. The graph shows the relationship between the number of points scored on a math quiz and the number of points scored on a history quiz. Judy makes the following statement. The trends in this data show that making an A on the math quiz would likely cause the student to make an A on the history quiz. Do you agree with Judy's statement and be ready to justify why? So think about that for about 5 to 10 seconds. Okay, raise your hand if you agree with Judy. You agree with Judy. Chase, why do you agree with Judy?
Because on the graph, the people that scored like high on their math got high on their history.
Good. Okay. Rohan, what were you going to say? Same as Chase? Ryan, were you going to say something? Same. So based on the, Andre, what do you want? Okay, good. Okay, all of your justifications make sense to me. It's a positive correlation. The graph is showing us that that's the case. Who disagrees? Colin, why do you disagree?
Because that's all those other people and math and history had stuff going on.
Hold on, let Colin speak.
Math and history are going on and you're not going to.
Okay, Jack, what are you going to say?
I was gonna say like you took it in another class, like with another school, you could get very different results because not everyone in social studies is good at math, and not everyone at math that's good at math is good at social studies.
I agree with that statement. Alex, what were you going to say?
Used to be scores first at school math, and then bonus is social studies.
Okay. Tyler.
I just want to point out that it was talking about, well, I mean, I'm kind of a little bit, I just want to point out being against their statement as in they were using real world examples when it was asked to leave a look at the graph and put a statement based off of it.
Okay. So, but here's the thing. So everything that everybody said, I agree with. Everybody that agreed based it solely on the data. Everybody that disagreed based it solely on real life, right? Like, I'm going to change one word, and let's see how you guys feel about that. If I take out the word cause and put influence, does that change the scenario? Okay. What I'm trying to get to on here, Yes, the graph shows that that's what's happening. Based on this graph, that's an assumption that I can make. It is not a cause and effect relationship, though. One does not cause the other to happen. One is associated with the other strongly based on this graph, but one does not cause the other to happen. So an A on math will not cause A on history, but they are associated. And we're going to get into a whole lot more of what's associated and what's cause and effect next week. But that word cause is what makes that false. One does not cause the other. They are associated. There are other factors that could go into this. Every person that made an A on the math quiz might study. And if you study for one subject, you probably study for other subjects. Okay? Or you know that maybe your strength is math, you need to study for history. Or your strength is history, you need to study for math. There's other things that go into that. So one does not cause the other. Good conversation. All right, number 4, pitches thrown and baseballs. The scatter plot shown on card B shows the relationship between baseball used in 14 games and the number of pitches thrown during these games. Draw a trend line or a line of best fit that models the data and write an equation for this line in point slope form. Now here's what I was talking about before. If I draw a line, I'm a human, right? I'm drawing a line on this graph. My line might be slightly different from somebody else's line. But what you're trying to do is you're trying to get the average of the data. You don't want to be super high above it. You don't want to be way far below it. You want to get into, does that look about right? Yeah. Okay. Into the average of the data. The closer the points on that graph are to my line means that it's a stronger correlation. What type of correlation is that? Positive. So when I go to write an equation, what needs to be true about my equation? Slope needs to be positive. Good. Is my slope going to be like 20? No. Right? All right. So we're going to pick 2 points on this graph, and you can estimate them. They don't have to be exact. So let's do
280 because it's right above 280.
280. Well, that's one. Okay, we'll estimate that right here. And then you said 260, 60. Okay. So see, these points are a little off of my line, but we don't want our slope to be like 37 over 18, right? Like that would just be a pain. So here, 260, 60, and 280, 120. Okay, so we're going to write point slope form. So 260, 60, and 280, 120. What did I say? So it's not going to be 20, but just look, 30. 30. No, not. 3. I don't want to do that. 3. Not 30. 3. Okay. My slope is 3. Okay. Y minus y1. It doesn't matter which point we use. Let's use the smaller of the 2. So y minus 60. Very good. Okay, so here is my equation for my trend line, my line of fit. Using your trend line, predict the number of baseballs that will be used if 275 pitchers are thrown. It says interpolation. What does that mean? Inside the graph. So 275 is inside the graph, so I can get an idea of what my answer should be. Based on my graph, what should my answer be? About 100, right? But now I have an equation. If I use my equation, what am I going to do? Plug it in. Where does 275 go? X. So 275 minus 260, 15 times 3 plus 60, 105. Were my answers close together? Yes.
Wait, why did you,
So 3 times 15, 45. I would subtract. I wouldn't. You have the values that are inside. It's going to be a lot easier for me to multiply by 15 than to do it by 275 and then end up doing it.
yeah, the only reason we have like that is because we did it.
Correct. I still just have X. Okay. Correlation coefficient. We use the letter R to represent correlation coefficient. We use the letter R. The actual graph for correlation coefficient goes from -1 all the way to +1. But they're only showing us from 0 to 1. They're only showing us from 0 to 1 because it is a positive correlation. So it cannot have a negative correlation coefficient. So remember when I said the tightness of the points represents how correlated it is or how strongly it's correlated? So since these points are pretty close, that means that it has a strong positive, which means that it's going to be closer to a 1 than a 0. A 0 means that there is absolutely no correlation at all, and a 1 is a straight line, perfect slope. Yes. Yeah. Well, you're looking at the points realistically, like how close the points are together. So if I went back and I looked at all of our positives, like these two are pretty tight, but this one is like if you see how these points are further away from each other, this one would be a weaker negative than that is a strong positive. Okay. Where am I at? Here we go. So next week we're actually going to find the correlation coefficient, but for right now we're estimating. This would be the weak side. This is strong. I would estimate R to be anywhere in this area. So anywhere from like 0.75 to 0.95-ish area. Okay? Okay. Yes. How I got such a large range?
No, like, how did you put it on the?
Because 0 is no correlation. When you look at those points and you look at your trend line, do I have a lot of points that are like way far off my line? We're using B. They're pretty close to a straight line. So the closer it gets to a straight line, the closer you get to 1 or -1. Okay. So add this to your paper. We're going, where do you need space? Yeah, just add it underneath where the original line is. You're going from -1 all the way to 1 because this is the actual scale. They only showed you half of it. 0 is no correlation. -1 is the strongest negative, and +1 is the strongest positive. Now, the first judgment that you make is the slope positive or negative? If it's positive, it's going to fall between 0 and 1. If the slope is negative, it's 0 and negative 1. But it never goes past 1 or negative 1. So as everything strengthens, it's moving away from 0. Right, as your points get tighter. So the first thing that I want you guys to do, because there's a ton of questions that get asked like this, you're going to arrange 4 correlation, yes,
Will it always be between like -1 and 1?
yes, yes.
So is this line other than slope?
It's how tight your points are to your slope. Okay, so I'm going to give you 4 correlation coefficients. And you're going to list them from strongest to weakest. Okay. Which one's the strongest? Very good. What about the next one? Very good. Very good. Okay, y'all caught on immediately. My first period, we had to do it a couple of times. The negative doesn't matter. Strength is polarizing. So you're looking for the largest absolute value. Take the negatives out, arrange them from greatest to least, and then throw the negatives back on. Okay? All right.
So number 1 was the strongest, right? No.
The strongest.
The strongest one was the first.
Strongest one was negative 0.98.
But why does it? I thought if it's closer to 1, it'd become positive.
1 or negative 1.
The closer you get.
0 is no strength, and strong goes from side to side.
Farther away you get from 0, the stronger.
Why does negative 98?
It's super close to
It's
negative.
over here.
Oh, that's
You're looking for the farthest one from 0.
I thought it was -2.
Okay, bring it back. Scatter plots on card F shows the relationship between absences and the final exam. Okay, we're not going to write an equation, but we're going to draw a trend line. So my trend line, what would be true about it?
Negative.
Negative. So my correlation coefficient is going to be negative. Are those points as tight as the last ones? No. So my correlation coefficient is not going to be all the way up at -1, but it's still, would you say that that is a negative correlation? So it's not 0 either. It's going to be somewhere around here, okay? And I'm putting a big range because next week you're going to put all of the things into the calculator, and the calculator is going to give you the exact correlation coefficient. But you need to understand the strength and what the strength means. Okay? Okay. Card D. High temperature and number of visitors at the beach. So let's draw a trend line. What would be true about my trend line? It's positive, strong correlation coefficient, positive correlation coefficient. It says to write an equation in multiple different forms. Let's make an estimation. Oh, we have till 37 minutes. I was sitting here thinking we got out earlier. Okay, let's pick 2 points then on the line, and we're just going to write point slope. I like this one.
30.
65. Oh,
64.
30.
No, that's like
29.
64, 30.
oh, look. Boom.
Hey.
Okay, this one is 85, 150. And the next one up was 90, 180. You can do it, it's number 6, just write the points underneath part A. And my slope. -30 divided by -5. 6. So y, don't worry about it. Y minus, let's use 90, 180. Minus 180. Okay, equals 6 times x minus 90. Okay. Using your trend line, predict the number of visitors that will be on the beach at a temperature of 120 degrees. Extrapolation. That's not interpolation. Extrapolation. If interpolation is inside, what is extrap? Outside. So make that note. This is outside. And if I go to make an estimate, I hit a roadblock because, no, it's outside. It's like way over here. 120. 120 degrees is way over here. My line doesn't even go over there. I agree with you. However,
Does it ever matter what points you choose?
they have to be close to your line. So like if the points that I pick are not close to your line, I bet whatever points you pick would be close to my slope. So you'd be fine. Okay, time out. Can I make a good judgment call if I'm trying to extend the line way outside of the graph? No. So this is when we have to use our equation, because with extrapolation, you can't get a good judgment call. So 120, where am I going to put that? X. Y minus 180 equals 6 times 120 minus 90. So
That's 630.
6 times 30, 180 plus 180, so 360. 360.
What?
What?
You get what?
120 minus 90 is 30. Times 6 is 180.
Oh, I forgot the one.
And then add 180. That's 360. 120 minus 90. What's your math on there? 180. Okay. It's 360 people. Is that reasonable? Why? Okay. No, it's not. 120 degrees is too hot. Yeah. Okay. Would anybody say yes, though?
Yes.
Why? It's reasonable based on the graph. So again, we're hitting a scenario, real life versus graph. In reality, my graph would look a little something like this, right? Because nobody's going to be at the beach once it hits a point where it's not healthy to be outside. Okay? All right. So that